VS Series Image Region Tool. Import and connect to the Region Tool simulator. We will use these sample images of playing cards to show how the image tools operate. Our goal is to look for flaws on this white surface area and ignore the complex pattern here. So we'll use the Region tool to do that. First, we will add a positioning tool, the ShapeTrax 3A tool, to locate the pattern, the target. So add the ShapeTrax 3A tool from the positioning category, and we'll use this image number 1 here, the 10 of hearts, as our model image. So we'll start there. So make sure on image 1 when you do that. So we'll make this be our model image. So we'll put our pattern tool, pattern region around the target. You can adjust as necessary. Okay, so draw your region, click OK. Now, in our example here, I'm going to put a mask on to ignore this inside area because eventually I want to locate some other patterned cards as well. So what we'll do is we'll put a mask on to ignore this inner area and we'll concentrate on that outline feature. So to do that, go back to the region and edit the pattern region. And then you can add a mask here. So what we'll do is we'll just add a simple rectangle mask, as you can see here. And then we'll just ignore this inner pattern area. And then again, just concentrate on just that outline feature. So this will locate basically any playing card regardless of the pattern inside it. And you can leave everything else default as far as the ShapeTrax tool. You can refer to the ShapeTrax 3A tool tutorial for more details on how that tool works, but we'll use everything else default. Okay, so to create the image region to inspect, let's go to the Add Tools section here, and it's in the Region category here. There's two image region tools, one for current image and one for model image. We'll show an example of each, but we'll start with model image. Model image is used for a fixed pattern, so it's a complex pattern, but it's fixed. It doesn't change from part to part. Current image can be used to adapt and change from part to part. So we'll start first with model image. Let's say in this first example, the pattern doesn't change. It's just complicated. It's the 10 of hearts, but it's always the 10 of hearts in this example. And then it just doesn't change. So, but we just want to inspect for flaws around and ignore that heart pattern. So add the image region model image tool to the task. And then what we'll do is we'll draw our region. We'll use the saved model. So we're going to use the same image model that we've already created with the ShapeTrax. So that's the model image that we're going to use because this is the pattern that we're going to look for. So, or use. So let me put this region, just put it around the entire card there. And I'm on image number 1, by the way, for reference in the film strip here. We'll use that as our reference image for the moment. And just click OK after you draw your region. So with the image region tool, your goal is to create a binary model or binary image of the region that you want to use for inspection. So in this example here, this white area is what we're interested in. So we want to create a binary image that creates a region or a shape that is going to be used in another tool to do the inspection. So you can see here, it automatically applies the binary filter. If you need to adjust the settings, you can go to the Image Enhance tab. You notice that this is a color camera. So it defaults to the RGB grayscale mode, the average grayscale, and then the binary filter is automatically applied. But if you need to, you can go into the settings and adjust if need be. For example, using color binary, if you wanted to binarize the red color, things like that. We're going to use the default RGB grayscale and then the binary filter as is for this example, because you can see we're getting a pretty good image of our shape that we want. Now, you can also add additional image enhancement filters if you'd like to create or generate the model that you need. In this example, what we'll do is we'll add one more filter. We'll add an expand filter just so it won't be so sensitive right at the edges of this target. So to add any filters, just click add, and then you can see the various filters. So what we're going to do in this example is just going to add one expand filter, and we'll use the default settings. And what that'll do is just expand the white area a little bit so it's not so tight on those edges. So if I turn this off, you can see the effect. So it just shrinks that black area and expands that white area a little bit so it's not so sensitive around the edges when we add our defect inspection tool. Make any further adjustments to the image as needed, but again, the bottom line is you're looking to create a binary image of the shape that you want to use for inspection. So in this case, it's this white area, and then we'll ignore this pattern area. So you can see if I play through these images, first 5 images here are all 10 of hearts. You can see it creates that, or it uses that model image. So that's all you need to do. You can go ahead and add our inspection tool now. So let's click add from the inspection tool category. And then we'll go flaw detection. Now, we could use a number of tools, whichever tool you want to use for this. We could use a defect tool. In this example, I'm going to go ahead and use the Grayscale Blob tool, but any tool you want to use to inspect for what you're looking for and utilize that image region that's been generated by the image region tool. So we're going to add the Grayscale Blob tool. Let's just simply add it, and then draw your inspection region around the target. All right, so I'm going to grab this box here. So just draw it around the whole card here. And again, we're going to use that image that's been generated, the region that's been generated, so you can make it a little bit bigger than the target, because we're going to ultimately reference that binary image shape that we've created. So right now, of course, the tool, Grayscale Blob tool, is looking for defects anywhere or detections anywhere in this region. So what we'll do is, again, reference that image region that was created. So to do that, go back to the region settings here, and then it's under options. So if you go under options, you can refer to the image region tool right here. So if you activate this, turn this on, then we can link it to that tool number 2 that we created that's creating that model. And if you want to do a preview, you can click preview and see what the region is. And then you can choose white or black. So here's the preview. So you can see we want to use the white area for inspection, but you can also choose the black area. So if you wanted to inspect for defects on the hearts, you could do that as well. But for our example, we're going to leave it on white, and then we'll adjust our settings accordingly. You can refer to the Grayscale Blob tool tutorial for more details on how this tool works. But you can see, if we go to image number 1 here, the background's slightly uneven here, but so it's a little too sensitive right now in the settings. So let's go to detection here. I'm just going to adjust the detection threshold of this tool. And again, you can refer to the tool tutorial for more details. But if we just raise our detection threshold up a little bit here, about 35 for now, but notice I'm on the contrast image, so now here's the good part, image number 1. It's looking pretty good, but you can adjust this detection threshold as needed, but our goal is to detect the defects within the pattern here. So you can see on image number 3, it's detecting some defects here. We'll see image number 4 here. It's still a little sensitive here at the edge, so I'm going to raise this just a little bit further. In fact, we'll set it to about 50. Our threshold. But again, you would adjust that depending on the application, but it looks like this setting will work for us. So if I scroll through these first 5 images, you can see the first one is a good part. Actually, let's go ahead and put our judgment on the tool. So if we put an upper limit of 0 for our label count, in other words, we don't want any defects, the tool will fail if it detects defects. So the first two images are good. And if I get to the third image, you can see it detects some defects. And if I change to the raw image here, you can see, in fact, there are defects within the target there. Image number 4 is good. And then if I go to image number 5, again, you can see there's defects detected, but it's only inspecting in this region, in this area here, and it's ignoring that pattern information because we created that customized region. So you can see it is easily detecting these defects around the pattern, and our detection is working quite well. So now if we go to image number 6 here, you can see the pattern now changes. So it's no longer the 10 of hearts. We have an ace of hearts here. So the pattern has changed. So model region only creates that customized region based on the model shape. So it's fixed. But if you need it to adapt, that's where the image region tool current image will be helpful. So let's do the same inspection now, but have it adapt to the shape so we can account for the different cards that come in, different patterns. The cards are used for this example, but let's say the pattern changes. So we still want to look for defects in this white area, but ignore the red pattern, and it will change. So let's go back to the first image for now, and then let's add, again, from the region category. This time we'll add the image region current image. So this one will be the one that will be dynamic, and it will adapt from part to part. So let's add this tool. And then what we'll do, of course, is draw our region around the target. So here's our rectangle. Just like before, I'm going to draw my region around the card, and then we'll set up our filtering. So get that drawn in, and then click OK. Okay, so if I play through some of these images, you can see it's creating a binary model now on the current image. All right, so every time a new part comes in, it creates that binary model. So our goal is the same. We want to create this binary image of the shape or region that we want. But if you notice, in this example, when you're using the current image, we need to account for these defects. So depending on the situation, depending on the color of the target and the defects, you might need to add some additional filtering to this. So if you notice, our defects are being detected in the binary image here. This is image number 3. So we don't want that, because if we use this region, it'll inspect everywhere but the defects. We need to account for that. And you can use some image filtering to account for that. So again, you can see we're using the default RGB grayscale and the binary filter, but we can apply additional filters, as mentioned before. So depending on the situation, you can use a variety of different filters, maybe some expand, shrink, etc. But one easy way to get rid of those small defects versus the background on a binary image is to use the blob filter. So in this example, we're going to use the blob filter, but again, use whatever filter is necessary to generate and create the region that you need. So let's add the blob filter. Now, the blob filter as a default has the fill holes turned on, so let's turn that off because we don't want it to fill in the target here. And then we'll set this up. So what we can do with the blob filter, what's nice about the blob filter is you can filter out smaller blobs. So in this case, we can filter out these smaller defects, assuming the defects are smaller than the pattern itself. So in this case, it is. So what we can do is, again, we'll turn the fill holes off. And if you scroll down in here, by the way, back up here, detection color, we want to set that to black because that's the objects we want to detect. So we'll detect the black. And if you scroll down on this filter, here's the detection color. So right now it's 255. So it converted those detections to white, and then the background is black. But what I'm going to do is I'm going to reverse this. So the blobs that are detected, I'm going to set that to 0, which is black, and then the background white. So you can manipulate this as needed to get your desired results. So you can see now we have this binary model back. So what I'm going to do then is I scroll down further, is you can have all these filters here. So one of the filters is the area filter. So that's the size of the object. So what I can do is put a lower limit on this area filter. In our example, I'm going to put 2000 as the limit. And then you can see it will eliminate those smaller blobs out of the picture here. And we are retaining our pattern information. So now we can use this region, this white area, to properly inspect for defects. And it will adapt from part to part, and it will filter out those defects. So adjust by using any other filters as needed, but in this case, we're good to go. So now what we'll do is we'll add another grayscale blob tool that will reference this region. So again, from the inspection section of the task, let's add another grayscale blob tool, just like we did previously. Except this time we'll reference the tool number 4 region, which is using the current image instead of the model region, model image. All right, so draw your region accordingly, just like before. And again, we're going to reference that region that's been generated. So just draw your rectangle around the entire target. And then again, just like we did in the last example, go back to region and let's turn on the shared image region tool. And then what we'll do is link it to tool number 4 this time, the current image instead of the model image. And just like before, once you activate that, you can preview, and we want that white area again. Okay, same as the previous tool, we need to adjust our detection threshold of the grayscale blob tool. So we use the same setting that we used in the other tool. I'm just going to set it to 50. So that should be sufficient for this example. So you can see, again, here's image number 1. We have cleaned that up and there's no detection. So let's set our judgment to 0, upper limit of 0 to the label count, and let's test this out. So let's just play through the parts. Here's the original images with the 10 of hearts. You can see it's still detecting those defects quite easily, just like before. And then we have the other target. So here's the ace of hearts. The shape has changed, but we've adapted to the current image, so it's detecting these flaws quite easily. You notice that it's detecting the flaw down here and inside the little A there. So again, we're adapting to the shape, creating that new image model each time, or region, and it's only inspecting in the areas around the pattern. So if I continue through these targets, you can see it's detecting these properly. Of course, this other tool is failing that we set up previously because that's set for the model region, and this one is set for the current image. All right, so it'll adapt. So you can see it's detecting these flaws no matter what the pattern. The pattern changes, but we're detecting these flaws no matter which pattern comes in. Let me fit this to screen here. And I'll just continue through the remaining targets here. And you can see the detection is quite stable. So just a quick summary, the image region tool can be very handy to generate a complex inspection region. So if the pattern is complex, it can be very handy to generate this complex region for inspection. So the model image version will create a complex region, but on the fixed model, whereas the current image will adapt from shape to shape. So depending on the situation, you can use the appropriate image region tool.